Hi everybody. In today's presentation, my colleagues Florian, Jayu, Johanna, and I are going to introduce you to natural language processing through the Nltk package for Python. So we're going to start with a brief introduction about natural language processing, and then we're going to help you to set up and install the Nltk package on your computers. And at a later stage, we're going to dive a little bit deeper into the codes and highlight specific features of this package. And in the end, we're going to sum it all up, give you some resources for further readings, and of course, listen to your questions. So before we start talking about natural language processing, or NLP, first, what is a natural language? So natural languages are simply the human languages which were created under specific circumstances and used in specific places, different places, and they were created also in different points in time, which makes it really hard to pin them down with explicit rules, especially that they were passed from generation to generation. So when we talk about natural language processing, which is also called computational linguistics, we do not only talk about word counts, but also we talk about the understanding of complete human utterances of that. So NLP covers any kind of computer manipulation of natural language and could be maybe at a later stage providing response or feedback on natural languages, which is currently happening. So as applications of these, we can talk about machine translation, which is not the only simple Google Translate feature, but also, for example, if I was Spanish, searching for a specific topic in Spanish, then my search engine will take this Spanish word, translate it into German maybe, look for relevant articles in German, and then it will give me back the result, not in German, but also in Spanish. And also we can simply use the NLP for information retrieval, finding a specific word in a set of documents, also for information extraction, and sentiment analysis, which is, for example, for the reviews on applications or on specific platforms, where you can, the computer can tell whether it was a positive or a negative feedback, and of course for chatbots that can identify keywords and based on that develop an answer and give it and send it back to the humans. So as long as we move forward and we increase the interface between humans and the machines, NLP is progressing. Now, about the Nltk package, it stands for Natural Language Toolkit. It was created in 2001, and it has really it covers a really large spectrum of natural language processing. So we chose it simply because it is free, it is open source, it has a large community, it's really well documented, it's consistent, simple and straightforward, modular, and extensible. So just to give you like a hint about the different modules of the Nltk package, as you can see here in this list, for every language processing task, we have a separate module that has specific functions. So if we were, for example, interested only in parsing, we don't need to learn everything about the collocation discovery or to tackle this module, which makes it really easier and really user-friendly. A normal Nltk workflow would start by retrieving some unstructured data, then do the pre-processing, and then at the end do the analysis and get the results. So in our presentation today, we chose specific tasks of the pre-processing that we're going to talk about, and for the analysis, we're going to talk about text classification, which is a method that assigns assigns a set of specific categories to open-end text, which is really helpful in organizing and in structuring documents. And now I will hand over to my colleague Florian, who's going to help you to install the package and talk a little bit about pre-processing.
All right, thanks, Nassim. So I'm going to go through the early steps of pre-processing data like tokenization and filtering stop words. But first, let's get started and install Nltk. And I'll jump over to Google Colab for this. So you can install the Nltk package using pip or conda. If you prefer using terminal on Mac or command prompt on Windows, you can just use pip install Nltk. And this will also work in Spider, Jupyter Notebook, or any other IDE. Just don't forget to put an exclamation mark there in the beginning. You can also install Nltk using conda install -c and a conda Nltk. Now, one of the great things about Nltk is that it comes with a lot of supplementary resources, even in multiple languages, such as collection of text samples, which are called corpora, lexical databases such as WordNet, and pre-trained models for NLP. And to access them, I'm just going to quickly show this in Spider because it doesn't work as well in Google Colab. So you have to import NLTK and then use NLTK download, which will open up a download manager with all the collections, corpora, models, packages that are available in NLTK. And we're going to use the popular package, which includes the most commonly used resources in NLTK. We can either download this here, or we can also, once we know which resources we want to use, we can also download this directly in Google Colab using NLTK download and then add our package that we want to download. And this will download all the resources included. Now, for the early steps of pre-processing data, I'm going to use the inaugural corpus, which contains text of all US presidential inaugural speeches. Now we can import this here, and this includes a number of text files for each individual speech, starting with George Washington in 1789. And for the early steps of pre-processing, I'm just going to use his second speech in 1793, which for the very simple reason that it's the shortest one ever delivered. That's just 135 words. And using the raw function, we can just take a look at this speech, which is a good example for the early steps of pre-processing data. And we're going to save this as Washington for now and go over to pre-processing your data. So the first step in turning unstructured data to structured data is tokenization. And tokenization essentially means splitting up text word by word or sentence by sentence into smaller tokens that a computer can work with. And NLTK provides a number of tokenized functions for sentences and words. So if we want to split text by sentences, we can use send, tokenize, and then add our Washington speech. And this will give us a list of 4 strings for each of the 4 sentences. If we want to split text by words, we can use word tokenize and then add our Washington speech. And I'm just going to quickly show you the first couple of tokens. So this gives us a list of strings that NLTK considers to be words. But we can already see that punctuation characters as well as stop words like by, the, of are included as separate tokens. And often we want to remove these because they don't add much value or meaning to your text. So we can remove stop words in NLTK using the stop words corpus. And here we just have to make sure to set this to English because also other languages are supported. And then we just initialize an empty list for our filtered words and run a simple for loop that iterates over our list of words. And will only add those words that are not in the stop word corpus to our filtered list, regardless of their uppercase or lowercase. So at the end, this will give us a list of strings that has removed our stop words. We can also remove punctuation characters. I'm going to skip this for now because we don't necessarily need NLTK for that, but just so you know. And then another interesting feature of NLTK is finding a concordance of words, which will allow you to see each time a word is used and with its immediate context. So if you, for example, want to know how the word nation has been used throughout US inaugural speeches, we can import a text module and then run a concordance function on the word nation. And this will give us all the instances a word has been used with its immediate context. Now, this won't give you a full picture for your analysis, but it's still interesting to kind of take a look and see if anything stands out. But for now, I'm just going to hand over to Johanna now for the next steps of pre-processing your data.
Thank you, Flo. And now I will give you a brief overview of stemming, POS tagging, and lemmatization. So-called stemmers remove parts of a word, leaving only the word stem. This allows you to focus on the basic meaning of a word rather than all the details of how it's being used, which comes in very handy for applications like sentiment analysis or text classification. First, we need to import the NLTK stem package. NLTK provides different stemmers supporting different languages, but for now we will use the snowball stemmer, which is especially good for English texts. Now we can set up the snowball stemmer and choose a language. Here, English. Let's stem a sentence that would probably never be part of a political speech. You will see why, but it shows how our stemmer works and also how it doesn't work. First, we create a string with the sentence, the crew of the USS Discovery discovered many discoveries. Discovering is what explorers do. Before we can start, we need to separate the words and store them in a list as we have seen before. And now we can create a list of stamped versions and print the results. You can see the step here. Let's see what happened to all words that started with discuff. We actually see that the results look a little inconsistent. The terms understemming and overstemming are two ways how stemming can go wrong. Understemming happens when two related words should be reduced to the same stem, but actually are not, as you can see in this example. Overstemming happens when two unrelated words are reduced to the same stem, even though they shouldn't be. This would be a false positive. We do have some other ways to reduce words to their core meaning. It's called lemmatization. But first, we will have a look at part of speech, basically meaning the traditional classes of words distinguished according to the functions performed in a sentence. POS tagging is the task of labeling words according to their part of speech. In English, there are at least 8 different parts of speech: noun, pronoun, adjective, verb, adverb, and so on. Let's now call the POS tag function and apply it to our word list. All the words of our list are now in a separate tuple together with a tag. But what do the tags mean? Fortunately, Nltk also provides a list with all tags and their meaning. That is definitely a lot to take in, but there are some patterns to help you remember what is what. You can see an overview here of the patterns, for example, that all nouns have a tag starting with the letters NN and so on. But now that we are familiar with part of speech, we can proceed to lemmatizing. Lemmatizing also reduces words to their core meaning, but it will give you an English word that makes sense on its own. For example, needed for interactive applications like chatbots. It is a more complex approach than stemming, takes more time to process, but gives you a meaningful output that is designed to be understood by humans. A lemma is basically a word that represents a whole group of words. For example, if you were to look up the word best in the dictionary, you will need to have a look at the entry for the word good, and so on. To be able to lemmatize, we need to import the relevant parts of Nltk, which is called the WordNet Lemmatizer. Now we can set it up and create a lemmatizer to use. And let's start with a noun to see the differences in what we've seen before in stemming. The lemmatizer gives the correct lemma, here the singular of the word scarves as an output. Problems can occur though if the lemmatizer doesn't assume the right part of speech. Like here, it gives the output worst. In these cases, we can make it clear that we want worst to be an adjective by adding a POS tag, which you can see here. The default parameters for POS are pretty intuitive. And now that you have an idea about preprocessing with Nltk, we will jump to the practical text classification task.
Thanks for Johanna's introduction. The next one, we're going to start by trying to use the movie reviews database that is part of the Nltk corpus. From there, we'll try to use words as features which are a part of either a positive or negative movie review. And the Nltk movie review data set has the reviews, and they are labeled already as positive and negative. This means we can train and test with this data. So first of all, we will load the movie review corpus, and then we can see that in each category we have positive or negative labels, and we will take all of the files IDs because each review has its own file ID. And then we will store the word tokenized version, which is a list of words from the document file ID, followed by the positive or negative label in one big list. So we've used the random package to shuffle our documents. This is because we are going to be training and testing. If we left them in order, chances are we train on all of the negative and only some positives, and then test only against positive, and we don't want that, so we shuffle the data, and then we will print the document. And as we can see, there are in this tuple there are one big list with tokenized words, and then another one is the label positive. Okay, and the next step we will create a new variable called word features, which contains the top 3,000 most common words. Next, we're going to build a function, and that we will find these top 3,000 words in our positive and negative documents, and making their presence as either positive or negative, because it will show in the next text classification task. And then so in this part. In this part, we will print one of the documents that has the 3,000 top words. So you can see for each word it has its own attributes, true, and then we can do it for all of our documents, saving the feature existence booleans and their respective positive or negative categories. And after that, we got all of the data that we need, and we need to set them, split them up into training set and testing set. So for the testing set, for the training set, we can get the documents from 0 to 1,900, and then we will use the rest part of our database for the testing part. Okay, and the next step, we need to choose the classifier. So here we will choose the naive Bayes classifier with Nltk to train our model for the text classification task. This is called supervised machine learning, because we are showing the machine data and telling it, hey, this data is positive and this data is negative. So we will put this data. We will feed this data for the classifier, and then we will we'll try to see the classifier accuracy percent. And here you can see that the classifier accuracy percent is only 75%. It's not that high. So actually, the naive Bayes classification is not that accurate. And then we can also print out the confusion matrix, so which is a summary of prediction results on a classification problem, and the number of the correct and incorrect prediction are summarized with count values and broken down by each class. So it's very useful. And then in the last step, we can show the most informative features. As you can see, that this word, there are some negative and positive labels here, and we can see that, for example, for the first one, sucks, it appears 10.1 times as often in negative reviews as it does in the positive reviews, which means that if we have these words in one document, this document will be more easier to be regarded as a negative movie review instead of a positive review. So that's it. So thank you for listening to our Nltk package introduction and the NLP introduction. So in the end, you can, if you want to know more about the NLPK or NLP, so you can visit the Nltk package website, and you can also read the very classical book called NLP with Passion, and you can also check the cheat sheet here, and you can also find the free tutorial in the following website. And these slides we will share with everyone later. Thank you.